I've got on the screen a notification here. I forgot to tell you these particular questions are questions on that review handout I gave you yesterday that deal with what we're going to be learning tomorrow in the final lesson of the unit. Okay, so you don't have to worry about those. Let's take a look at any questions that you might have. Does anybody have any questions you would like me to go over from this handout? Go ahead, Ian.
For question 17,
Yes?
um, wanting in the form root AB, how do we know that the A and the B stand for different numbers or different digits?
If they didn't, we wouldn't have A and B there. How could they? I'm wondering what you're asking here. You mean how do we know that there are two digits under the root?
Yes.
Because there's two letters under the root.
But doesn't, so does that mean that a letter doesn't always signify a number?
No, you just because a letter can signify two numbers. But if you see two letters, it's two numbers. If A were three numbers in this question and B were two numbers, it would make no sense for me to put AB. The fact that I'm putting AB is telling you there are two digits. If I put root A, I'm not telling you how many digits it is. So when you see AB, it must be two digits. But when you see just A, it doesn't mean it must be one digit. I mean, it's a logic thing that what I'm getting at is just because one thing is true logically in one direction doesn't mean the opposite is true. For example, all chickens are birds. Not all birds are chickens. Okay, so the conclusion that you draw about seeing two digits, A and B, is that there are two digits. You cannot draw the conclusion if you just see A that there's only one digit.
I wasn't trying to draw that conclusion. I was thinking that A was a separate number, regardless of how many digits there are in A, and you're multiplying it by B. Right? Yeah, that's where I was.
No. If the number under the root sign is 17, then A is 1 and B is 7. This is not intended to mean A times B. It's intended to mean there's a two-digit number. The first digit is A and the second digit is B. Have I answered your question now? Okay. Sorry, it took me a while to get what you were asking. Other questions? Go ahead, Jonathan. 19? So we have a point that's on a terminal arm of a rotation angle. And again, this is what I would describe as a fairly standard run-of-the-mill type of question. Okay. The whole idea of us having these definitions for sine, cosine, tangent, cosecant, secant, and cotangent. This whole idea here, and some of it is from Math 20, combined with, well, this is part of it, but combined with the fact that these 6 trigonometric ratios take on positiveness or negativeness depending on the quadrant they're in, is what this question, number 19, that you're asking about is all about. And it's a fairly common thing. If I were to, I mean, I'll maybe do this. I'll break down the exam for you and talk about it on Thursday, but I would say probably in the multiple choice numerical response section, you're looking at maybe at least 4 of those questions being this, which means, 20% of that section of the exam is this kind of stuff. So when we're told that the point -4, 2 lies on the terminal arm, what does that mean? Well, Negative 4 comma 2. I'm not sure we need a diagram here, but I'm going to put it. This is negative 4. This is positive 2. And we have a terminal arm that passes through that point. There's the vertex of the terminal arm, and it's passing through that point. And this is the rotation angle we're talking about. So if I said to you, what is tangent of the rotation angle, and I know it doesn't say what is tangent of the rotation angle, but if I said, what is tangent of the rotation angle, tangent is defined as y over x, which would mean that the tangent of this rotation angle would be 2 over negative 4. And again, I honestly don't believe here, everybody, that the diagram really adds much to what's going on, because ultimately you're going to go to this definition, right? And you can see in the question y is 2 and x is negative 4. Now the question is, what is the exact value of cosecant? So we have to figure out, you're writing an exam, so it wasn't tangent, I was just illustrating something. You have to figure out, you're writing in the middle of an exam, and you see, well, what is cosecant of theta? Well, cosecant of theta, I'm going to write this a different way. I'm just going to write sine of theta and cosecant of theta are reciprocals. Of each other. So what that means is if I know cosecant, I can go 1 over whatever that thing is equal to and say that's equal to sine. If I know sine, I can go 1 over that to find out what cosecant is. And the reason why I'm doing this is because I think it's reasonable for most people to know without much thought that sine is y over r. Okay? And what that means is that cosecant must be r over y. So this right here, Jonathan, this is the answer to the question. Right? If we can figure out what r divided by y is, we get the answer. Now we already know x and y. X is negative 4 and y is 2, and we know that x squared plus y squared equals r squared. So this allows us to find r. So you're going to square negative 4 and get 16. You're going to square 2 and get 4. You're going to get r squared equals 20. So r equals root 20. Okay, so I've got a big mess of information here, but what we now know is x equals negative 4, y equals 2, r is equal to root 20, and you're asked to determine cosecant, which we've already figured out is r over y. So cosecant of the angle is r over y, which means cosecant of the angle is root 20 over 2. And now we don't need to check the quadrants here to find out whether it's positive or negative, because you were told x and you were told y. It's defined as being where x is negative and y is positive. The only thing that remains here is noticing that that's not one of the answers, but you should be able to go back to math 20-1 and realize that root 20 can be broken up into root 4, root 5, and you see the answer, I can tell by the look on your face. So I'll just finish this. What we're doing is we're taking root 20 and we're rewriting it as a mixed radical in simplest form by finding a perfect square that's a factor. And I know there are a couple of you that prefer to take 20 and use a factor tree and get 2 times 2 times 5 and then pull the 2 2's out as a 1 outside. That's just not my preference. This is over 2, so what happens is 2 divided by 2 cancels, and you're left with this answer. Cosecant of theta is simply equal to root 5. You know, I wouldn't expect that anybody has to do this, but if you're confident in your work and you've determined that cosecant of theta is root 20 over 2, and maybe you're getting the exam sweats and your brain is kind of shutting down a bit, you know, this is a multiple choice question. One of those answers is equal to root 20 over 2. So you could take your calculator and go root 20 divided by 2, closing the brackets on the root 20, and then go through your list. Well, clearly, obviously, it's not A and it's not B, right? Because those are negative. Does that help, Jonathan? Okay, good. Other questions? Go ahead. 32, Adrian? You really have to get used to the idea that on exams at this level, sometimes you're given questions that you don't actually have numbers to work with. You have, I don't want to call them variables because they're not variables. They're letters that stand for numbers. They're, I guess, parameters maybe. So you're told in question 32 that you have a terminal arm that passes through a particular point, but you're not actually given the coordinates of the point, which tells you, by the way, is just an interesting idea, that since there's an answer to this question, it doesn't matter what B is. Like, just let that sink in. If there are numerical answers to what sine of the rotation angle is, and cosine of the rotation angle, and tangent of the rotation angle, what these things are all equal to, if there's an answer, then apparently it doesn't matter what B is. So I'm going to come back to that idea in a bit. But if you're asked to determine the sine of the rotation angle, let's just start off with that. Sine of a rotation angle is y over r. Now what do we know? Well, looking up here, the point that it passes through, and you know, I could do the same kind of diagram I did before. It passes through b, comma, negative 2b. So it passes through that point, and this is the rotation angle. I don't know how much that adds to the solution here, other than to point out that angle is determined by the fact that the y-coordinate is negative and it's twice as big as the x-coordinate. So if the x-coordinate was 5, the y-coordinate would be negative 10. It would pass through that point. If the x-coordinate were 1, the y-coordinate would be negative 2. It would pass through that point. All of these points on this terminal arm, all of these points are going to have y-coordinates that are negative 2 times the x-coordinate. Okay, and again, I'm going to come back to that kind of ratio idea in a bit. So what do we know? We know that x is equal to b and y is equal to negative 2b. In order for us to find out what sine of theta is, we need to figure out what r is. Like so far, all we have here, Adrian, is that sine of theta is equal to y, which is negative 2b, over r. But we don't know r. So we're going to use the Pythagorean Theorem here to find r. In the context of coordinate trigonometry, again, this is the Pythagorean Theorem. So I can put in b for x, negative 2b quantity squared for y squared equals r squared. And I'm going to simplify that. So when I square b, I get b squared. When I square negative 2b, when I square the quantity of negative 2b, the negative 2 squared becomes 4, and the b squared becomes b squared. So I'm left with this. Now I can add these together. I have 1b squared plus 4b squared, that's 5b squared, equals r squared, which means r is the square root of 5b squared. And just to remind you, everybody, r is always positive. So we don't need to worry about plus or minus here. So how can we simplify this? Well, just going back to Math 11, the square root of a product is equal to the product of the square roots. I mean, that's maybe not how it was taught to you, but that's a fact. The square root of AB is equal to the square root of A times the square root of B, if A and B are being multiplied together, right, Ian? Like, not in that question that you asked about. So the nice thing about this is b squared as a square root just becomes b, and you're left with root 5 multiplied by b is equal to r. So where were we? We were at sine of theta. I'll just rewrite it. It's easier for me to rewrite it than to scroll up again. And we said that y was equal to negative 2b. And we've discovered that r is equal to root 5 multiplied by b. And what happens is the b's cancel. And I'm back to that idea that it didn't matter what b was. The b's cancel, so I'm left with negative 2 over root 5. And in terms of a multiple choice exam question, what we can do is start figuring out which of these potentially could be correct. Well, it's not C, because the first thing in the list has to be sine of theta. It's not D. So we've got sine of theta. You could repeat this whole process for cosine, but I would figure out tangent right now. Because well, it doesn't matter. We know r now, so it really doesn't matter. But tangent of theta is equal to y over x. So we could write tangent of theta is equal to negative 2b over b. And the b's cancel, so you see that tangent of theta is negative 2. And that means a is out. Cos of theta is x over r. We'll just finish this off. Although we know what the answer is. Cos of theta is x over r. Well, x is b and r is root 5 multiplied by b, so the b's cancel and I'm left with 1 over root 5. So the correct choice is choice B. Does that make sense? Okay. Now, going back to the very beginning, I told you apparently since there's an answer, it doesn't matter what b is. So if you wanted to, you could have just made up a number for b. And as we get deeper into the course, we'll discover that this is a strategy that very often is helpful. Let's just say it passes through that point. The fact that it passes through that point means that it's this type of question that Jonathan had asked about, right? Where you know the x and the y coordinate and you're asked to find a trigonometric ratio. And you would discover that whether you chose 2, negative 4, or 8, negative 16, you're going to get the right answer. By the way, if you ever choose numbers to make it work, choose numbers that are simpler. I would choose 1 and negative 2. Other questions? Go ahead. Of course. Ian.
For 22.
Yes.
A little bit confused the way you graphed it, and I was wondering how come I chose A, and if that is correct, how come on the graph it does not show that negative, or show that pi over 2 is a variable?
Okay. First of all, I like the idea that you're looking at a graph, but I want to point out to you, everybody, that I haven't officially taught you how to solve equations graphically. That we're going to do in the very first, maybe in the second lesson of the next unit. But we can talk about that now. What I want to do first, though, with everybody is show everybody how to solve this algebraically. And then I can get to your question about why you're maybe not seeing all of the answers on your graph. Is that the nature of your question? Okay. So, first of all, you can solve any equation graphically. We've learned this. You could graph y1 equals the left side and y2 equals the right side and look at the x coordinates of the intersection points. Or you could zero the equation and graph the whole thing as y1 and look at the x-intercepts. And I normally don't even discuss this, but we are going to discuss it in this unit because of your question. And what I'm telling you is that you can solve trigonometric equations on your graphing calculator. But what I'm also reminding you of is you have to know how to solve them algebraically because that could be evaluated on an exam. Whether it's a written response or, Peppermint Patty solved this equation, where did she make a mistake? That type of question. So solving this algebraically means that since it's quadratic, we have to zero the equation. That's what must be done when you solve equations algebraically that are trigonometric and quadratic. Since it's quadratic, we can factor it, and since it's one of these quadratic equations that does not have a constant term, everybody, I factor out the common factor of sine of x. And that leaves me with sine of x minus 1 as another factor. Now we go back to kind of a Math 20 idea where we say, well, if two things multiplied together give you 0, then if the first thing gives you 0, it makes the equation true. And if the second thing equals 0, it makes the equation true. Now, both of these, let me rewrite the second equation. Both of these little equations are ones in which the reference angle idea on your calculator kind of is a bit of a letdown. Because if you, and we can try this, if you put your calculator in degrees and you find the reference angle here, you're going to get 0 degrees. But I want you to confirm that. Yes? And if you put your calculator in degrees and you find the reference angle here, remember, reference angle means you go inverse sine, in this case, of the number. I believe you're going to get, well, no, I know you're going to get 90 degrees, right? So let's talk about the one on the right first. If the reference angle is 90 degrees, you would follow this kind of logic. You would say, since sine is positive, we're talking about in quadrant 1 and quadrant 2 where the y coordinate is positive. You with me on that, Ian? Okay. But if it's in quadrant 1 with a reference angle of 90 degrees, then it's 90 degrees away from the x-axis in quadrant 1, and that puts it there. If it's in quadrant 2 with a reference angle of 90 degrees, I got these backwards. This was quadrant 2, but if it's in quadrant 2 with a reference angle of 90, it goes up to here. If it's in quadrant 1 with a reference angle of 90, it goes up to here. So the location is the same no matter what here, right? So the only solution for the rotation angle, theta, well, it's x, but I'm going to call it theta. For the rotation angle is 90 degrees. It doesn't matter whether you're thinking quadrant 1 or quadrant 2. If you find the reference angle here, you get 0, and then we have a problem, because when I eyeball what the sine is equal to, it's not positive and it's not negative. So, you know, how do you use the concept of a reference angle here? And I would say you can't really do it. You have to know that sine is the y coordinate over r. So even if you're not looking at the unit circle, the only way y over r could be 0 is if y is 0. So we're looking at these two locations. The reference angle thing is a clunky idea if the locations are on the axes anywhere. It just doesn't work all the time. Anyway, from 0 to 2 pi, and I need to look at this question here, it includes 0, but it does not include 2 pi, right? According to this. So this position here can be labeled as 0 rads. As 0 rads. This position here is pi rads. Man, having a difficult time here. Is pi rads. This position over here, I said 90 degrees, but we would say pi over 2 rads. We could keep going all the way around past pi, back to 2 pi or up to 2 pi, but that's not in the domain. So those are the three solutions. And you're okay with that? Okay. So now let's talk about solving this graphically, which again, I'm reminding you, if I give you a multiple choice question, you can use what I'm about to discuss to get the answers. But I have a question for you, Ian. I think we're done with this. When you solved this graphically, did you graph y1 on the left side and y2 on the right, or did you zero it and graph the whole thing? Okay, so since we have sine squared of x equals sine of x, I just want to make sure, Ian, you graphed this as, say, y1, and you graphed this as y2, and you're finding where they cross or intersect or touch. Okay, well, this is maybe good we're having this discussion because I think it might add a few marks to some of your exams, because if you really get stuck, you can do this. But remember, I'm likely to ask you how to solve an equation algebraically on a written response. Okay, so what Ian did was he entered in sine squared of x. Now, I'm of the opinion that really when you enter sine squared of x, you should be entering that. Okay, that's what it means. But I will tell you right now that if you enter this, it will square sine and not x. This is correct. This means sine of x quantity squared. To me, it looks like sine of x squared, but it's not. Okay. And then we're also going to go sine of x. Now, but I have an interesting problem here. I'm going to want to see my answers in radians. I want radian answers, but I won't recognize them necessarily. I mean, I will recognize 0, definitely. But you remember one of our solutions was pi over 2? That means these graphs are going to intersect at this x coordinate, and I won't necessarily recognize it. I will now because I've just seen it. So what I'm thinking is the best strategy is to make sure we're in degree mode, and then find the points of intersection in degrees and then just convert them to radians. Now we want to look from 0 to 2 pi. I have a couple of choices here. One of the things I can do is go zoom trig, and everybody remember that that will zoom from basically negative 360 to 360. You with me on that? Except I don't want negative 360 to 360, I only want 0 to 360. So hitting zoom trig gave me a nice picture, but what I want to do is go in here and edit the window settings and maybe start at negative 30 degrees and make sure I go up past 360 so I can see at 360. So I might go up to 390. The other thing, and you don't have to do this, but let's take a look at these graphs. This is sine squared of x. And here comes sine of x. There is a lot of wasted space here and here, isn't there? And if I look at the ticks, it goes from negative 4 to 4. I think if I go from negative 2 to 2, I can shave off the top and the bottom wasted space areas and stretch out the graph to see it better. I'm just teaching you a little bit of window setting strategy here. So now I can go negative 2 to 2, and I want to find the points of intersection. So the first thing to note when I look at this, and your calculator is pretty clunky, it's not very smooth, it's almost box-like, is I see there are definitely points of intersection, right? I can see visually, and we can zoom around if you want to confirm this, but I can see visually that they appear to intersect here, they appear to intersect here, they appear to intersect here, and they appear to intersect up here. So do they intersect at 0? We can see they do. Do they intersect at 360, which is a complete cycle? Yes, they do. We could confirm that by going to the Calculate menu, choosing Intersect. Now, since I have only 2 functions on there, I don't need to worry about choosing first or second. I just have to scroll close to, well, let's do this one. Close to that intersection point. And basically then hit Enter 3 times, and it tells me that they intersect at 90 degrees. I hope. Or was this the problem you were having? Oh, there it is. Oh, it went to that one. So That's baffling to me. Let me zoom in on that peak. That's the point you were talking about then. Let me zoom in on that peak by using zoom box.
That's what I did as well.
And it still didn't work, eh?
Correct. What I did later is I went to the maximum, and I saw that both maximums were the same.
Yeah, and what you could also do, I wasn't going to do that. What I was going to suggest is, I've never really realized this before. These two graphs touch there, right? But they don't cross through each other. And I suspect that when your calculator finds a intersection point, it's maybe looking for where they cross. And since these two don't cross, it can't do it. It really surprises me. What I could also do is, I mean, you can recognize that's at 90 degrees, right? So you could go to your table settings. Or maybe this might be better. Just change it to ask. Go in here and enter 90 and see if you get the same thing for each, and you do. By the way, and now I'm getting into the next unit, but that's okay. It might be helpful for your exam. If you go to your table settings and you start at 0 and go up by 15 automatically in degree mode, you're going to hit 30 degrees. You're going to hit 45, you're going to hit 60, you're going to hit 90, you're going to hit all of those special angles on the unit circle. So if you see a question like this, where you have all of these special angles, and you do this, and go to your table, you can see they are equal at 0, so 0 is a solution. You can see they are equal to each other at 90 degrees, so pi over 2 is a solution. You can see they are equal to each other at 180 degrees, so pi is a solution. We've stumbled onto a flaw in the programming of the calculator. So this was central to your question, right? Why can't it find that? And I don't have an answer to that question, but it does intersect there, as you've shown by looking at the maxima, and I've shown by looking in the table. I just want to show something to you briefly here before we go on. So are you satisfied with that, Ian? Okay. Well, let's take a look at number 28. Okay, we have time. So I'm going to take a look at number 28. And I'm going to imagine that you were asked to solve this on a written response question. Okay. And by the way, this is not a question that you could put the answers into the equation and check, because the answers are going to be rounded. So what you would do here is, first, well, I'm just going to rewrite the equation first, is subtract 2 cos x from both sides and get 1 equals 3 cos x. Divide both sides by 3 and get cos of the rotation angle equals 1/3. And then proceed to, you can't use the unit circle here. Cosine of the rotation angle equals 1/3 is somewhere on the unit circle, but it's not one of those special angles. It's not one of those special locations. So what we do is we go into reference angle mode. And I would like everybody to find the reference angle. But since we want an answer in decimals in radians, put your calculator in radians. There's no need to put it into degrees, because it's not going to be a special angle. And you're going to have to do a conversion then to turn it into radians. So when I put my calculator in radian mode, and I take the inverse cosine of 1/3, I get a reference angle of 1.23 radians. Okay, then what we do is we eyeball the trigonometric ratio. We notice that it's positive. It's a cosine. cosine is positive wherever x is positive, that means it's going to be in quadrant 1 or quadrant 4. And I realize I could have just put these both on the same grid, but I don't generally like doing that. So we would sketch a reference angle of 1.23 rads and a reference angle of 1.23 rads. And then we would say that x, the actual rotation angle, can be found by finding each of those. So one of them will be 1.23. The other will be 2 pi minus 1.23. 5.05. So you get 5.05 rads. And you're done. And I would say that, if you truly understand this and you're really qualified with trigonometry, this is a very quick question to answer. But, and maybe we should all be thankful that Ian asked about this question, because I'm getting into the next unit, and after this lesson in the next unit where we solve graphically, many people go, oh man, how come we didn't know this before? It would have made our lives so much easier for multiple choice questions. If I want to solve this equation, and I want the answers in radians, I can put my calculator in radians. I can enter 1 plus 2 cos x for the left-hand side as y1 and 5 cos x for the right-hand side. Now you need to be aware of something. And it's that y equals 5 cos x, and you guys know this. Y equals 5 cos x has an amplitude of 5. And when I go zoom trig, it only goes negative 4 to 4. So, we may not see the whole graph. We might have to correct something. You also are not really aware of what 1 plus 2 cos x looks like as a graph, because that's in the next lesson. But who cares what they look like? I'm about to see what they look like. Now, there's a problem here, right? What's the problem? What just happened? What is this telling me I forgot to fix? Ian?
Are you in 360?
Right. The last time we did a graph, I went zoom trig and I was in degree mode. And then I said, oh, let's find a reference angle, and I changed it to radians. So I have to, when you see a mess, whether it's like a heartbeat kind of thing, out of control, or maybe a flat line, you've got to go zoom trig again. Now in the next unit it will get more involved than just going zoom trig. But if I go zoom trig, okay, now I'm grounded again. I feel better. There's 1 plus 2 cos x. There is 5 cos x. Now looking, first of all, when we solve things graphically on the calculator, I don't want to leave you with the impression that we don't have to understand trig to get the answers here. You have to understand many things, and one of them is that this graph goes essentially from 0 to 2 pi and 0 to negative 2 pi in the opposite direction when we're in radians and go zoom trig. So looking at this question, we wanted answers between 0 and 2 pi. So we want the answers in here. Well, they intersect here and here. All we have to do is find those points of intersection and we will have our answers. The x-coordinates of those points will be the answers to this question. So I don't even need to worry about the fact that I'm clipping off the top of one and the bottom of one of the functions. I can just go to my calculate menu, choose intersect, scroll close to this one, hit enter 3 times, (1.23 rads). If you go to the other one, you'll get 5.05 rads. And I actually believe that, as I kind of alluded to, understanding the connection between the trigonometric equation and these graphs is still a valuable set of skills. You're not just blindly following steps. You have to understand what's going on. I mean, you could take this to an extreme. The extreme being something like number 25, which, yeah, disappointment's the wrong word. I would never say I'm ever disappointed with people. But as a teacher, maybe I'm disappointed in myself that anybody in the room would have to rely on a graph to solve this. This is really a Math 20 problem where you can rearrange this and write 2 sine x equals root 3, which means sine of x equals root 3 over 2. These are exact values, so you ought to be able to find a reference angle if that's your thing, or you ought to be able to use the unit circle if that's your thing, and get the answers very quickly. I know how people struggle in this unit with equations, so this may be very simple to some of you, but I'm going to spend some time doing it. Let's do a reference angle approach here. What is the reference angle? Find a reference angle here. 60, isn't it? 60 degrees. And by the way, when we want an exact value, you see these numbers in the choices, they're exact values. Not like this that were decimals. When you want exact values, then you need to put your calculator in degree mode to recognize those numbers. So when you go inverse sine of root 3 over 2 in degree mode, you get a reference angle. You get a reference angle of 60 degrees, but that means it's pi over 3. And then, so this is not a unit circle approach. Then you're eyeballing the trigonometric ratio, which is this. You're seeing it's positive. You should know that sine is positive in quadrant 1 and quadrant 2. So you put pi over 3 as a reference angle in each. And then the rotation angle is 2 pi over 3 and pi over 3. The answer is A. Pi over 3 plus multiples of 2 pi over 3 plus multiples of 2 pi. But could you solve this equation right here graphically? Sure. But do it in degree mode so that you recognize the answers. And now I'm switching modes again, so you better remember that you're going to have to go zoom trig. I'll show you what happens if you don't. So I change it to degrees, and I graph y equals 2 sine x. And I graph y equals root 3. There's nothing wrong with graphing y equals a constant number. It's just going to be a flat horizontal line. But there's 2 sine x. It doesn't look right. It doesn't have that waviness to it because I'm in the wrong mode again. It's too flat. So you have to go zoom trig. Oh, there we go. That's y equals 2 sine x, and this is from 0 to 2 pi. And you can see there's 2 intersection points. By the way, I don't know if you remember I set my table up to start at 0 and go up by 15. I do that whenever we have exact values, and I can go to my table. I can see that they have the same value at 60 degrees, pi over 3. They have the same value at 120 degrees, 2 pi over 3. I could find the intersection points to be 60 and 120. Now I've opened up the door here for lots of possibilities on multiple choice questions. Anyway, thank you for asking that, Ian. Other questions? All right, we have about a half hour left in class, so you have about a half hour to practice more problems. Remember that there is an extra practice thing up here. I think most of you picked it up yesterday. or some of you did anyway. If you need some more extra practice, there's this. You could also go back to your textbook and look at the sections that we've covered, which so far are all of chapter 4, and I believe the first 2 sections of chapter 5.